Could this material make humans invisible? Scientists call it real, not magic, and its secrets may shock you. Imagine a material that could bend light itself, making anything behind it vanish from sight. Sounds like science fiction? Not anymore. Researchers have already built strange metamaterials that can create the illusion of invisibility. But could they ever work on humans? For centuries, humans have dreamed of becoming invisible. From ancient myths about cloaks of disappearance to H.G. Wells' classic The Invisible Man, the idea has haunted our imagination. But unlike fiction, real science doesn't deal in magic. It works through physics, and physics has discovered that bending light waves is the key. If you can redirect photons around an object, they won't bounce back to the human eye. The result? You wouldn't see the object at all. This is exactly what scientists are now trying to do with metamaterials, engineered substances that interact with light in ways nature never could. So, what exactly are metamaterials? These are not ordinary materials like glass or plastic. They're specially engineered with microscopic structures smaller than the wavelength of light. Imagine a forest of tiny patterns, guiding light as if it were water flowing around a rock. By arranging these structures carefully, scientists can force light to curve around objects instead of bouncing off them. This phenomenon is called negative refraction. It's bizarre but real. And with this, objects could appear to vanish, at least to the naked eye or cameras. It's the closest real-world step we've ever taken toward invisibility. The first serious attempt at invisibility came in 2006, when scientists at Duke University built a prototype cloaking device. It didn't make people disappear, but it did bend microwaves around an object. That meant radar couldn't detect it. An exciting proof of concept. Imagine a small cylinder hidden on a table. When viewed with microwave detection, it simply wasn't there. While it wasn't visible light yet, the principle was groundbreaking. Suddenly, invisibility was no longer just fantasy, it was a problem of engineering. And once radar cloaks worked, everyone began asking, when would the human eye be fooled? The challenge was clear. Microwaves are long, but visible light waves are incredibly short. To hide something from human eyes, metamaterials must be engineered on a nanoscopic scale, smaller than a single wavelength of light. That's like sculpting patterns thousands of times thinner than a human hair. It's not impossible, but it's insanely difficult. Early prototypes only worked in 2 dimensions, hiding things from a single direction. Still, each step showed that bending visible light wasn't just possible, it was happening. Researchers in places like Berkeley and London began racing toward the Holy Grail, true optical invisibility. Whenever invisibility is mentioned, people instantly think of Harry Potter's cloak, but reality is far trickier. Fiction makes it look like fabric with magical powers, while real science involves rigid, carefully engineered sheets. Imagine wearing armor made of high-tech lenses instead of a silky cape. It doesn't flow, it doesn't shimmer. It's more like carrying a personal optical device strapped to you. Scientists laugh at the comparison, but they also admit the fiction inspires the science. After all, many physicists today grew up watching fantasy movies. The dream of invisibility remains a powerful motivator. Of course, the first major interest wasn't magic shows, it was the military. Imagine vehicles, tanks, or even soldiers invisible to the naked eye. Defense agencies around the world invested heavily in cloaking research, especially after Duke's breakthrough. While full invisibility was far off, partial cloaks could hide vehicles from infrared cameras or radar. Even if soldiers couldn't vanish in daylight, stealth at night was already a game changer. Companies like Hyperstealth even experimented with quantum stealth fabric, which bends light to obscure outlines. Military dreams drove funding, pushing the technology faster than pure academic curiosity could. In 2012, a Canadian company called Hyperstealth Biotechnology revealed a material they nicknamed quantum stealth. It wasn't true invisibility, but it could bend light in such a way that objects behind it were blurred, distorted, and nearly gone. Demonstrations showed soldiers and equipment disappearing behind panels of this material. The catch? It only worked from certain angles and distances. Critics argued it was more like advanced camouflage than invisibility. Still, it proved that light could be manipulated in practical, scalable sheets, not just lab experiments. Suddenly, the line between sci-fi and reality grew razor thin. It might surprise you, but cloaking technology already sneaks into everyday devices. Think about fiber optic cables. They bend light with precision. Or anti-reflective coatings on glasses, which redirect glare. Even smartphone screens use principles of light manipulation to make images sharp and vibrant. While these aren't full cloaks, they're built on the same physics. Scientists realized cloaking wasn't just about invisibility for humans. It had potential in medicine, communications, and computing. Imagine surgeons seeing through their own hands during an operation, or cables that transfer data at light speed without interference. The possibilities go far beyond Harry Potter tricks. In 2011, the British Army tested a cloaked Challenger tank using cameras and projectors. The system worked like high-tech camouflage. Cameras captured the scenery around the tank, then projected it back onto panels, making the vehicle blend with its background. To the eye, it looked almost transparent at a distance, but up close, distortions gave it away. This wasn't metamaterials, but adaptive camouflage. Still, it revealed a powerful truth. Invisibility didn't always need physics-bending materials. Sometimes clever illusions worked just as well. Military interest skyrocketed, showing that the race to invisibility could take multiple technological paths. By the mid-2010s, labs from Berkeley to Imperial College London were racing ahead. They created metamaterials that could cloak tiny objects from visible light, though only from limited angles. Imagine hiding a paperclip, but only if you looked straight on. Not impressive for soldiers, but revolutionary for science. Each success proved invisibility wasn't fantasy, just engineering limits. Suddenly, invisibility wasn't about if, but when. Surgeons saw potential beyond spy games. Imagine doctors using cloaking sheets to see through their own hands during delicate surgery. By bending light around obstacles, medical teams could gain an X-ray-like view without radiation. While still experimental, cloaking inspired medical optics, from better microscopes to clearer imaging. Invisibility, it turned out, wasn't only about hiding, it could also mean revealing. Nature has been cloaking long before humans. Think of octopuses, which can camouflage instantly, or glass frogs, whose bodies are nearly transparent. Some fish use reflective scales that bend light underwater, blending perfectly. Scientists study these creatures to inspire biomimicry designs. If animals can bend light biologically, maybe humans can engineer it synthetically. Not all invisibility is high-tech. Some researchers experimented with lenticular lenses, the same kind used in 3D postcards. Arranged in sheets, they can make things appear to vanish from certain perspectives. It's cheap, it's clever, and while imperfect, it shows invisibility doesn't always need nanotech. Sometimes, optical illusions can fool us just as much. Here's the catch. Cloaking isn't perfect. Most prototypes only work from one angle, or a narrow wavelengths of light. Move your head, and the illusion breaks. Worse, the materials are delicate, expensive, and often limited in size. A cloak big enough for a human? Still science fiction. But every year, the flaws shrink, and the dream inches closer. If humans could truly disappear, what would that mean? Privacy would vanish. Spies could infiltrate anywhere. Criminals could escape justice. On the other hand, activists and journalists in dangerous places might survive because of invisibility. Technology is never just about can we, it's always should we. Cloaks might not just hide people, they could change society. Think smaller, glasses that turn transparent when you look at your hands, or cars whose blind spots vanish using cloaking panels. Even simple consumer electronics could benefit. Cloaking isn't just for disappearing, it's for making the world more visible. Think of it as a way to delete obstacles from sight rather than people. Many scientists believe invisibility for humans could be real in the next few decades, but not as flowing cloaks. More likely, it'll be bulky panels or digital cloaks projecting surroundings. Still, the concept is alive and racing forward. Every experiment brings us closer to a reality once locked in myth. Invisibility might not be magic. It might be just another tool in the future tech box. When you strip away the hype, invisibility isn't about trickery, it's about physics. Light is just waves, and waves can be guided. By bending them, we can decide what the eye sees or doesn't see. The real magic cloak is the one woven by mathematics, engineering, and human curiosity. And that story is still being written. So, could this material make humans invisible? Not yet, not fully. But from metamaterials to clever illusions, the journey is real, exciting, and unfolding faster than ever. Today it hides objects, tomorrow maybe vehicles, and someday, who knows?